Architecture and structure of computer system, classification of computers, principles of modern computer architecture. In computer engineering, computer architecture is a set of rules, the methods that describe the functionality, organization, and implementation of computer system. The architecture of a system refers to its structure in terms of separately specified component of that system and their interrelationships. Some definitions of architecture define it as describing the capabilities and programming model of a computer, but not a particular implementation. In other definition, computer architecture involves instruction set, architecture design, micro architecture design, logic design, and implementation. Some history. The first documented computer architecture was in the correspondence between Charles Babbage and Ada Lawrence, describing the analytical engine. When building the computer Z1 in 1976, Konrad Zuse described in two patent applications for the future project that machine instruction could be stored in the same storage used for data, e.g. the stored program concept. Two other early and important examples are John Newman 1945 paper, first draft of report on the ADVAC, ADVAC, which described an organization of logical elements, and Alan Tonin more detailed proposed electronic calculator for the automatic computing engine. Also 1945, and which cite John Van Neumann paper. The term architecture in computer literature can be traced to the work of Lyle R. Johnson and Frederick P. Brooks, a member of Machine Organization Department in IBM Main Research Center in 1949. Johnson has had the opportunity to write proprietary research communication about the Stretch and IBM developed supercomputer for Los Alamos National Laboratory. To describe the level of details for discussing the luxuriously embellished computer, he notes that his description of formats, instruction types, hardware parameters, and speed enhancements were at the level of system architecture, a term that seemed more useful than machine organization. Subsequently, Brooks, a Stretch designer, opened a chapter 2 of book called Planning Computer System, Project Stretch, by stating, computer architecture, like other architecture, is the art of determining the needs of the use of a structure and then designing to meet those needs as efficiently as possible with economic and technological constraints. Brooks went on to help develop the IBM system 360, now called as IBM Z series. Line of computers in which architecture became a noun defining what the user need to know. Later, computer users came to use the term in many less explicit ways. The earliest computer architectures were designed on paper and then directly built into final hardware form. Later computer architecture prototype were physically built in the form of a transistor logic (TTL) computer, such as the prototype of the 6800 and the PARISC tested and tweaked before committing to the final hardware form. As of the 1990s, new computer architecture are typically built, tested, and tweaked inside some other computer architecture in a computer architecture simulator, or inside FPGA as a soft microprocessor, or both, before coming of the final hardware form. Subcategories. The discipline of computer architecture has three main subcategories. Introduction define the machine code that a processor read and acts upon as well as the word size, memory addresses, modes, processor registers, and data tape. Microarchitecture, also known as computer organization. This describes how a particular processor will implement the ICA. The size of computer CPU, computer processor unit, cache for instance is an issue that generally has nothing to do with the ICA. System design includes all of other hardware components within a computing system, such as data processing, other than the CPU, computer processing unit, i.e. direct memory access, visualization, and multiprocessing. There are other technologies in computer architecture. The following technologies are used in bigger computers like Intel, and were estimated in 22 years to count for 1% of all computer architecture. Microarchitecture architectural layers more abstract than microarchitecture. Assembly instruction set architecture. A small assembler may convert an abstract assembly language common to a group of machines into a slightly different machine language for different implementation. programmer visible macro architecture. High-level language tools such as compiler may define a consistent interface for contract of programmers using them, abstracting difference between underlying ICA, UICA, and macro architecture. For example, the C and C++ or Java standards define different programmed visible macro architecture. Microcode. Microcode is software that translated introducing to run on a chip. It acts like a wrapper around the hardware, presenting a preferred version of the hardware's instruction set interface. This instruction translation facility gives chip designers a flexible option, IG1. A new improved version of the chip can use microcode to present the exact same instruction set as the old chip version. So software targeting that instruction set will run on the new chip without need changes. Microcode present a variety of instruction sets for the same underlying chip, allowing it to run a wider variety of software. Pin architecture. The hardware functions that a microprocessor should provide to a hardware platform. Also, messages that the processor should emit so that external cache can be invalidated. Pin architecture functions are more flexible than ICA functions because external hardware can adapt to new encoding or change from a pin to message. The term architecture fits because the function must be provided for compatible system, even if the detail methods change. Computer organization. This slide shows structure computer, desktop computer, and this includes basic hardware component. This computer. Computer organization helps optimize performance-based products. For example, software engineers need to know the processing power of processor. They may need to optimize software in order to gain the most performance for the lowest price. This can require quite a detailed analysis of the computer organization. For example, in an SD card, the designers might need to arrange the card so that the most data can be proceed in fastest possible way. Computer organization also helps plan of selection of a processor for a particular project. Multimedia projects may need very rapid data access, while virtual machines may need fast interrupt. Sometimes certain tasks need additional components as well. For example, a computer capable of running a virtual machine needs virtual memory hardware so that the memory of different virtual computers can be kept separated. Computer organization and feature also affect power consumption and processor cost. Implementation. An instruction set and microarchitecture have been designed and practical machine must be developed. This design process is called the implementation. Implementation is usually not considered architecture design, but rather hardware design engineering. Implementation can be further broken down into several steps. Logic implementation designs the circuit required at a logic gate level. Circuit implementation does translator level designs of basic elements that may be implemented at the logic gate level or even at the physical level if the design calls for it. Physical implementation draws physical circuit. The different circuit components are placed in a chip floor plan or on a board, and the wires connection them are created. Next, design validation tests the computer as well to see if it works in all situations and all timing. Once the design validation process starts, the design at the logic level and test using logic emulation. However, this is usually too slow to run a realistic test. So, after making correction based on the first test, prototypes are constructed using field programmable gate arrays FPGA. Most hobby projects stop at this stage. The final step is to test prototype integrated circuits which may require several redesigning. For CPU computer processor units, the entire implementation process is organized differently and is often referred to as CPU design. About personal computer. The personal computer is one of the most common types of computer due to its versatility and relatively low price. Desktop personal computers have a monitor, keyboards, mouse, and computer case. This computer case holds the motherboards, fixed or removable disk drives for data storage, the power supply, and main contain other peripheral devices such as modem or network interface. Some models of desktop computers integrated the monitor and keyboard into some case as the processor and power supply. Separating the elements allows the user to arrange the computers in pleasing, comfortable array. It's the cost of managing power and data cable between them. Laptops are designed for portably but operate similar to desktop PC, personal computer. They may use lower power or reduced size components with lower performance than a similar process priced desktop computer. Laptop contains the keyboard, display and processor in one case. The monitor in the folding upper cover of the case can be closed for transportation to project the screen and keyboard. Instead of a mouse, laptop may have a touchpad or pointing stick. Tablets are portable computers that use a touch screen as primary input device. Tablets generally weigh less and smaller than laptops. Some tablets include fold-out keyboards or offer connection to separate external keyboards. Some models of laptop computers have a detachable keyboard, which allows the system to be configured as a touchscreen tablet. They are sometimes called two-in-one detachable laptops or tablet-laptop hybrid. Personal computer case. The computer case encloses most of components of the system. It provides mechanical support and protection of internal elements such as the motherboard, disk drives, and power supplies, and control and direct the flow of cooling and air over international components. The case is also part of the system to control electromagnetic interference radiation by the computer and protects internal parts from electrostatic discharge. Large tower case provides space for multiple disk drivers or other peripherals and usually stand on the floor, while desktop case provide less expansion room. All-in-one style designs include a video display built into the some case. Portable and laptop computers requires cases that provide impact protection for the unit. Hobbyists may restore the cases with colored lights, paint, and other features in activity called case modding. Power supply. Power supply units, PCU, convert alternating current AC electric power to low voltage direct current DC power for the computer. Laptops can run on built-in rechargeable battery. The PCU typically uses a switched mode power supply, SMPS, with power, MOCFET, power metal oxide semiconductor field effect transistor, used in the convert and regulator circuits of the SMPS. Motherboard. The motherboard is the main component of a computer. It's board which integrated. It is a board with integrated circuitry that connects the other parts of the computer, including the CPU, computer processing unit, and RAM, random access memory, and disk drive, CD, DVD, hard disk, or any other, as well as any peripherals connect via the port of the expansion slot. The integrated circuit IC chips is computer typically contains billions of tiny metal oxide semiconductor field effect transistor. Components directly attached to or to part of the motherboard include the CPU, central processing unit, which performs most of the calculation, which enable a computer to function, and is referred to as the brain of the computer. It takes program instruction from random access memory, interpreters and processors them, and then sends back result so that the relevant component can carry out the instruction. The CPU is a microprocessor, which is fabricated on a metal oxide semiconductor integrated circuit chip. It's usually called by heatsink and fan or water cooling system. Most NEVA CPU includes an on-die graphics processing unit, GPU. The clock speed of CPU governs how fast it executes instruction and is measured in gigahertz. Typical values lie between 1 gigahertz and 5 gigahertz. Many modern computers have the option of overclock the CPU, which enhanced performance at the expense of greater thermal output and thus a need for improved cooling. The chipset, which includes the NOS bridge, mediates communication between the CPU and other components of the system, including main memory, as well as source bridge, which is connected to the NOS bridge and support auxiliary interfaces and buses. And finally, Super I/O chip connected through the source bridge, which supports the slowest and most legacy components like serial ports, hardware monitoring, and fan control. Random access memory, which stores the code and data that's being actively accessed by the CPU. For example, when a web browser is opened on the computer, it's taken up memory. This is stored in the RAM until the web browser is closed. It's typically a type of dynamic RAM, such as synchronous DRAM, SDRAM, where MOS memory chips store data on memory cells consist of MOSFETs and MOS capacitors. RAM usually comes on dual inline memory modules, DIMM, in the size of 2 gigabyte, 4 gigabyte, and 7 gigabyte, but much larger, but can be much larger. Read-only memory room, which stores the BIOS that runs when the computer is powered on overrise begins execution, a process known of boot strapping or booting up. The RAM is typically a non-volatile BIOS memory chip, which stores data on floating date, mouse feed memory cell. Basic input-output system, BIOS, includes both firmware and power management firmware. Never motherboards used unified extensible firmware interface, UEFI, instead of BIOS. Buses that connect the CPU to various internal components and to expand cards for graphics and sound. CMOS, complementary MOC, battery, which power and CMOS memory for data and time or in the BIOS chip. This battery is generally a watch battery. The video card, also known as graphic card, which processes computer graphics. More powerful graphics cards are better suited to handle strenuous tasks such as playing intensive video games or running computer graphics software. A video card contains a graphic processing unit, GPU, and video memory, typically of type SDRAM, both fabricated on MOS integrated circuit, MOS IC chips. Power MOSFETs make up the voltage regulator module, VRM, which controls how much voltage of other hardware components receive. Expansion cards. An expansion cards in computing is a printed circuit board that can be inserted into an expansion slot of a computer motherboard or backplane to add functionality to a computer system via the expansion bus. Expansion card can be used to obtain expand of features not offered by the motherboard. Storage device. Storage device is any computing hardware in digital media that is used for storing, porting, and extracting data, files, and objects. It can hold and store information both temporarily and permanently, and can be internal or external to a computer, server, or any similar computer device. Data storage is a core function and fundamental components for computer. Fixed media. Data is stored by a computer using a variety of media. Hard disk drives, HDD, are found in virtually all older computers due to their higher capacity and low cost, but solid state drives, SSD, are faster and more power efficient, also currently more expensive than hard drives in terms of dollar per gigabyte. Are often found in personal computer built post 2007. SSD use flash memory, which stores data on most memory chip consists of floating gate MOCFET memory cells. Some systems may use disk array controller for greater performance or reliability. Removable media. To transfer data between computers and external flash memory device, such as memory card or USB flash drive or optical disc, may be used. Their usefulness depends on being readable by other systems. The majority of machines have an optical disk drive, ODD, and virtually all have at least one universal serial bus, USB port. Additionally, USB sticks are typically pre-formatted with FAT32, the file system, which is widely supported across operating system. Input and output peripherals. Input and output devices are typically housed externally to the main computer chassis. The following is a standard or very common to many computer systems. Input device allows the user to enter information into the system or control its operation. Most personal computers have a mouse and keyboard, but laptop systems typically use touchpad instead of a mouse. Other input devices include webcams, microphones, joysticks, and image scanners. Output device. Output devices are designed around the sense of human being. For example, monitor display text that can be read. Speakers produce sound that can be heard. Such device also could include printers or braille embossed. Mainframe computer. Mainframe computer, informally called a mainframe or big iron, is a computer used primarily by large organizations for critical application, like bulk data processing for tasks such as census, industry and consumer statistics, enterprise resource planning, and large-scale transaction processing. A mainframe computer is large but not as large as a supercomputer and has more processing power than some other classes of computers, such as mini computers, servers, workstation, and personal computers. Most large-scale computer system architectures were established in 1960, but they continue to evolve. Mainframe computers are often used as servers. The term mainframe was derived from the large cabinet called a mainframe that housed the central processing unit and main memory of early computers. Later, the term mainframe was used to distinguish high-end commercial computers from less powerful machines. Modern mainframe design is characterized less by raw computational speed and more by redundant international engineering, resulting in high reliability and security, extensive input-output facilities, which the ability to flow to separate engines. Strict backward computability with older software. Higher hardware and computational utilization rates through visualization to support massive throughput. Hot swapping or hardware such as processing and memory. Design mainframe computer. Modern mainframe design is characterized less by raw computational speed and more by some characteristics. In the late 1950, mainframe had only a rudimentary interactive interface, the console, and used sets of punched cards, paper tape, or magnetic tape to transfer data and programs. They operated in batch mode to support back-office functions such as payroll and customer billing, most of which were based on repeated tape-based sorting and margins operation, followed by line printing to pre-printed continuous stationary. When interactive user terminals were introduced, they were used almost exclusively for application, rather than program development. Typewriter and teletype devices were common control consoles for system operation through the early 1970s. Also, ultimately supplemented by keyboard display devices. By the early 1970s, many mainframes asked interactive user terminal, operating as time-sharing computers, supporting hundreds of users simultaneously, along with batch processing. Users gained access through keyboard terminal and specialized text terminal (CRT) displays with integral keyboards, or later from personal computer equipped with terminal emulation software. By the 1970s, many mainframes supported graphic display terminal and terminal emulation, but not graphical user interfaces. This form of end-user computing became obsolete in the 1990s due to the advent of personal computers provided with GUI. After 2000 years, modern mainframes partly or entirely fast out classic green screen and color display terminal access for end users in favor on web-style users interface. The infrastructure requirements were drastically reduced during the mid-1990s when CMOS mainframe design replaced the older bipolar technology. Characteristics mainframe. Modern mainframes can run multiple different instances of operating system at the same time. This technique of virtual machines allows application to run as if they were on physically distinct computers. In this role, a single mainframe can replace higher functioning hardware services available to conventional services. While mainframes pioneered this capability, visualization is not available on most families of computer system. So not always to the same degree or level of sophistication. Mainframe can add or hot swap system capacity without disrupting system function. With specificity and granularity to a level of sophistication not usually available with most server solution. Modern mainframe, notably the IBM Z series, System Z9 and System Z10 servers, offer two levels of visualization: logical partitions and virtual machines, VRM operating system. Many mainframe customers run two machines, one in their primary data center and one in their backup data center. Fully active, partially active, or standby in case is catastrophe affect the first building. Test, development, training, and production workload for application and database can run on single machine. Except for extremely large demands where the capacity of the machine might be limited. Such a two mainframe installation can support continuous business service, avoiding both planned and unplanned outage. In practice, many customers use multiple mainframes linked either by parallel multiplex and shared DACD in the IBM case. Citation need of this shared geographic dispersed storage provided by EMC or Hitachi. Mainframes are designed to handle very high volume input and output and emphasize throughput computing. Since the late 1940, 50, mainframe design have include subsidiary hardware, which manage the I/O device, leaving the CPU free to deal only with higher speed memory. It's common in mainframe shops to deal with massive database and files. Gigabyte of terabyte size records files are not unusual. Compared to typical PC, mainframes commonly have hundreds and thousands of times as much data storage online, and can access it reasonably quickly. Other server families also offload processing and emphasize throughput computing. Mainframe return on investment ROI, like any other computing platform, is dependent on this ability to scale, support mixed workload, reduce labor costs, deliver uninterrupted services for critical business application, and several other risk-adjusted cost factors. Current market mainframe computer. IBM with Z Systems continues to be major manufacturer in the mainframe market. In 2000 year, Hitachi so developed the Z series Z900 with IBM to share expenses, and the latest Hitachi IP 10,000 models, and made by IBM. Unisys manufacturers ClearPass Libra mainframes based on early Burroughs MSCP products, and ClearPass Dorado mainframes based on Sperry Univac operating system 1100 product line. Hewlett-Packard sell its unique non-stop system, which is acquired with tandem computers, and which some analysis classify as mainframes. Group Ball GCOs, Stratus Open VOS, Fuji, formerly Siemens, BS 2000, and Fuji ICL VME mainframes are still available in Europe, and Fuji, formerly Amdahl, GS21 mainframes globally. NEC with ACOs and Hitachi with AP 10,000 still maintain mainframe business in the Japanese market. The amount of vendor investment in mainframe development series with market share. Fujitsu and Hitachi both continue to use custom compatible processor as well as other CPU for lower end system. BAL uses a mixture of Itanium and Xeon processors. NEC uses Xeon processor for the low end ACOS2 line, but develops the custom NOH processor for ITS high-end ACOS4 series. IBM also develops custom processor in-house such as ZEC20. Unisys products produce code-compatible mainframe system that range from laptop to cabinet-size mainframes that use homegrown CPU as well as Xeon processor. Furthermore, there exists a market of software application to manage the performance of mainframe implementation. In addition to IBM, significant market competition include BMS and other technology. Starting in 2010 years. Cloud computer is now less expensive, more scalable, alternatively commonly called big data. Differences from supercomputers from mainframe. A supercomputer is a computer at the leading edge of data processing capability. With respect to calculating speed, supercomputers are used for specific and engineering problems, high-performance computer, with which crunch number and data, while mainframes focus on transaction processing. The differences are: mainframes are built to the reliable for transaction processing, as it's commonly understood in business world. The commercial exchange of good, service, or money. A typical transaction, as defined by the Transaction Processing Performance Council, updates a database system for inventory control, airline reservation, or banking by editing records. Transaction may refer to set operating including disk, read-write, operating system calls, or some form of data transfer from one subsystem to another, which is not measured by the processing speed of the CPU. Transaction processing is not exclusive to mainframes, but is also used by microprocessor-based server and online networks. Supercomputer performance is measured in floating point operation per second, FLOPS, or transfers edges per second, TEPS. Metrics that are not very meaningful for mainframe application, while mainframe are sometimes measured in million of instructions per second. Also, the defines depend on the instruction mix measure. Example of integer operation measured by MIPS include adding number together, checking values or moving data around in memory. Floating point operations are mostly addition, subtraction, and multiplication with enough digits or precision to model continuous phenomena such as weather prediction and nuclear simulation. In terms of computer speed, supercomputers are more powerful. About supercomputer. A supercomputer is a computer which with high level performance as compared to general purpose computers. The performance of computers is commonly measured in floating points operation per second, instead on million instructions per second. Since to 2017, there are supercomputer which can perform it our 1017 flops, 100 quadrillion flops, or 100 PF loops. For comparison, a desktop computer has performance in the range of hundreds of gigaflops to tens of teraflops. Since November 2017, all the world fastest 500 supercomputers run Linux-based operation system. Additional research is being conducted in the United States, the European Union, Taiwan, Japan, China to build faster, more powerful and technologically superior exascale supercomputers. Supercomputers play an important role in the field of computation science and are used for a wide range of computation intensive tasks in various fields, including quantum mechanics, weather forecasting, climate research, oil and gas exploration, molecular modeling, and physical simulation. They are such as simulation of early moments of the universe, airplane, spacecraft aerodynamics, and detonation of nuclear weapons and nuclear fusion. They have been essential in the field of cryptanalysis. Supercomputers were introduced in 1960 and for several decades fastest were made by Seymour Cray and Control Data Corporation. Cray Research and subsequent companies bearing his name or monogram. The first such machines were highly tuned conventional designs that run more quickly than their more general purpose contemporaries. Through the decade, increasing amounts of parallelism were added, with one of four processors being typical. In the 1970s, vector processor operating of large arrays of data came to dominate. A notable example is a highly successful Cray 1 of 1976. Vector computer remained the dominant design into 1990s. From then until today, massively parallel supercomputers with 10 of thousands of the self-processor become the norm. The US has long been the leader in the supercomputer field. First through Cray, almost under uninterrupted dominance of the field, and later through a variety of technology companies. China being increasingly active in the field as in June 2020. The fastest supercomputer on the top 500 supercomputer list is Fujaki in Japan with lean pack benchmark score of 415 PF lobs, followed by Summit by around 266 lobs. China and Italy have 2 each. Switzerland has 1. In June 2018, all combined supercomputers on the top 500 list broke the first exaflop max. About history supercomputer. In 1916, UNIVAC built the Livermore atomic research computer, today considered among the first supercomputers for the US Navy Research and Development Center. It still used higher speed drum memory rather than newly emerging disk drive technology. Also among the first supercomputers was the IBM 7030 Stretch. The IBM 7030 was built by IBM for the Los Alamos National Laboratory, which in 1955 had requested a computer 100 times faster than any existing computers. The IBM 7030 used transistor, magnetic core memory, pipelined instruction, prefetch data through a memory controller, and included pioneering random access disk drives. In 1961, despite not meeting the challenge of hundredfold increase in performance, it was pushed the Los Alamos National Laboratory. Customers in England and France also bought the computers, and it became the basic for IBM 7950. Harvest and supercomputer built for cryptanalysis. The third pioneer supercomputer projects on early 1960 was the Atlas at University of Manchester, built by a team led by by Tom Kilburn. He designed the Atlas to have memory space for up to million words of 47 bits, 48 bits. But because magnetic storage with such a capacity was unaffordable, actual core memory of Atlas was only 1600 watts, with a drum providing memory for faster 96,000 watts. The Atlas operating system swapped data in the form of page between the magnetic core and the drum. The Atlas operating system also introduced time sharing to supercomputing, so that more than the program could be executed on the supercomputer at any one time. Atlas was a joint venture between Ferrari and Manchester University, and was designed to operate and processing speed approaching an microsecond per instruction, about a million instructions per second. Classification computers. Classification of computers based via list and two parts. Classification of computer based on purpose, and classification by the functionality and size. Classification computer based on purpose. A computer is broadly classified into two categories according to their purpose: general purpose computer, specific purpose computer. General purpose computer is designed to perform a common range of tasks. These types of computers have the ability to store multiple programs. They can be used for business application, scientific purpose, for education, and for more use. Even though such computers are versatile, they are not much efficient and also slower in speed. Specific purpose computers. Specific purpose computers are made to perform a specific task, or it can handle a single specific task. They are not designed to handle multiple programs. Hence, they lack versatility, since they are made to handle two specific tasks. They are more efficient and faster than general purpose computers. These computers are used for satellite tracking, air traffic control, airline reservation. Classification computer based data handling. The computer is further classified into three categories to their data handling capabilities, or how they process the input data in different manner. They are digital computer, analog computer, hybrid computer. Digital computer. A digital computer deals with data that can store it in a binary format, i.e. in the form of 0 and 1. The data or information in this computer is stored in voltage pulses which represent as 0 or 1. Any type of data, whether it may be a text document, music files, or graphic images. All are converted into binary format before it can be stored in computer memory. It's a device that manipulates discrete data and performs arithmetic and logical function. Analog computer. Analog computer is used to process the analog data. The analog data is continuously changing or varying data. The analog computer is used to measure the conditions varying the aspect of physical quantities, like an electrical current, voltage, hydraulic pressure, or other electrical and mechanical properties. Analog computers does not measure the described values. They are used in scientific and industrial application. Hybrid computer. A hybrid computer constitutes both analog and digital computer system. The hybrid computer has the capability to process the input in both the analog and digital formats. The analog portion of the system can handle the continuous varying aspect of complex mathematical computation, whether the digital portion handles the numerical and logical operation. The digital portion also acts as control of the system. Example, hybrid computers are used in medical science to measure of heartbeat of the patient, also used in control industrial process and scientific application. Classification computers on computer based on their functionality and sizes. Upper we show about information about supercomputer and mainframe. In this part we are discuss about next type computer. The computer is divided into 4 categories based on their physical size, functionality, and application. They are supercomputer, we list above, mainframe computer, mini computer, microcomputer. About supercomputer, we are take information. Mini computers. The age of mini computers started in 1960s when Digital Equipment Corporation (DEC) realized the first DEC PDP-8 mini computer in 1968. Like mainframes, most mini computers are multi-user and general purpose computers. The major difference between mainframe and mini computers is that mini computers are slowed even if they perform the same type of task as mainframes. For example, PDP series. Microcomputers. Microcomputers is most commonly used computer that is generally used at home. School, banks, office, etc. It's a small, low-cost digital computer that consists of a single microprocessor, storage unit, and unit output device, input-output device. This microcomputer is generally made for individual use only. They were originally called microcomputers because they are much smaller in size as compared to supercomputers and mainframes. They are commonly used in home, office, personal use, hence also called a personal computer. The microcomputers include desktop computers and portable computers like a laptop, personal digital assistant, PDA. Desktop computer, or more popularly known as PC, personal computer, is the most commonly used microcomputer. It consists of CPU, central processing unit, keyboard and mouse as input units, monitor or display units as an output device. The CPU consists of microprocessor, main memory, secondary storage unit, like hard drive, optical drive, power supply, unit that is housed in a single cabinet. Some of the major desktop computer manufacturers are IBM, Apple, Dell, and Hewlett-Packard. Portable computer. Other than desktop computer, portable computers like laptops and PDAs have become more favorite among individuals. The best part of this portable computer is that it can be easily carried along by the individual. Laptops too consist of all the computers as the desktop computers constitutes, but they are more compact and smaller in size. Another portable computer is a portable digital assistant, PDA, which is the size of the palm. Hence, it's also called in laptop computers. The PDA are used to organize schedules, take important notes, set reminders and mathematical calculator, play games, and even surf internet and send emails. Apple launched the first PDA called Newton in 1993. The other most commonly used PDA are Palm Pilot, Handprint Visitor, HP Jordana, Compaq Aero, Franklin, eBookman, etc. But nowadays PDAs are replaced by smartphones. Smartphones are handheld device that combine the features PDA and cell phones. Smartphones are the popular handheld device among the individuals and are used to store information, perform mathematical calculation, surf internet, and email. and is used for voice calling. However, the features of smartphone are more oriented towards cell phone. The features of PDA are add-on facilities in smartphone. Industrial personal computer. In industrial personal computer, computer intended to industrial purpose, with form factor between a net top and server rack. Industrial PC have higher dependability and precision standard, are generally more expensive than customer electronics. They often use complex instruction sets such as 86 processors. This reduce instruction sets such as IRM volt overrides BUs. Some history. IBM realized in 5531 industrial computer in 1984 years, arguably the first industrial PC. The IBM 7531, an industrial version of IBM IT PC, was released May 21 in 1985 years. Industrial computer source first offered the 6531 industrial computer in 1985. This was proprietary for rack mount industrial computer based on clone IBM PC motherboard. Application. Industrial PC are primarily used for processor control, data execution. In some cases, an industrial PC is simply used as front end to another control computer in a distributed processing environment. Software can be custom written for a particular application of the self package, such as TwinCat. Analog device not exclusive sales for OEM European industrial market, and provides Mac SIM combined IBM and Mac. An application may supply requires the serial port offered the motherboard of. In other cases, expansion cards are installed to provide analog and digital I/O. Specific machine interface, expanded communication port, and force as required by the application. A subset of individual PC is the panel PC, where display typically an LCD. Principles of modern computer architecture. Concepts. In a sense, a computer is a machine designed to process, store, and retrieve data. Data may be numbers in spreadsheets, characters of text in documents, dots or color in image, waveform of sound, or state of the some system, such as an air conditioner or CD player. All data is stored in the computer as numbers. It's easy to forget this when we're deep in C code. Contemplating complex algorithm and data structures. The computer manipulates the data by performing operating of the numbers. Displaying an image on a screen is accomplished by moving an array of number of the video memory. Each number representing a pixel of color. To play an MP3 audio file, the computers read an array of numbers from disk and into memory, manipulates those numbers to convert the compressed audio data into raw audio data, and then outputs the new sets to number to the audio chip. Everything that a computer does, from web browsing to printing, involves moving and processing numbers. A computer system is composed of many parts, both hardware and software. At the heart of the computer is processor. The hardware that executes the computer programs. The computer also has memory, often several different types in the same. In one system, the memory is used to store programs while the processor is running them, as well as store as data the program is manipulating. Processor. The processor of most important part of computer. The components around which everything else is centered. In essence, the processor is a computing part of the computer. A processor is an electronic device capable to manipulating data. Data as information in a way specified by a sequence of instructions. The instructions are also known as opcodes or machine codes. This sequence of instruction may be altered to suit the application and hence computers and programmable. A sequence in instruction constitutes a program. Instructions in a computer are numbered just like data. Different numbers, when read and executed by a processor, cause different things to happen. A good analogy is the mechanism of a music box. A music box has rotating drum with little bumps and raw prongs. Sequences on instruction if a machine code program. Each type of processor has different instruction set, meaning the functionality of the instruction. Basic system architecture. The processor alone is incapable of successfully performing any task. It requires memory for program and storage, support logic, and at least one device, input-output device, used for transfer data between the computer and outside world. Picture show basic computer system. Microprocessor is a processor implemented usually on a single integrated circuit, with the exception of those found in some large supercomputers. Nearly all modern processors are microprocessors, and the two terms are often used interchangeably. Common microprocessor in use today more the Intel Pentium series and other. Microprocessors is sometimes also known as CPU. Microcontroller is a processor, a memory, and some devices contained within a single integrated circuit and integrated for use in embedded system. Data flow. This form computer architecture is known as von Neumann machine, named after John von Neumann, on the originator of the concepts. With very few exceptions, nearly all modern computers follow this form. Von Neumann computers are what can be termed control flow computers. The steps taken by computers are governed by the sequential control of a program. In other words, the computer follows a step-by-step program that governs its operation. Each location in memory space has a unique sequential address. The address of memory location is used to specify that location. The memory space is also known as address space. And how that address space is partitioned between different memory and input-output devices is known as memory map. The addresses space is the array of addressable memory location in 80-bit processor, such as 68 HCC11, which 16-bit processor bus. This word works out to be 216 memory. Hence, the processor is said to have 64K kilobits address space. Processor with 32-bit address buses can access 4 gigabit of memory. Some processors, notably the Intel 86 family, have separate x86 family have separate address space for input-output devices with separate instruction for accessing this space. This is known as input-output. However, most processors make two distinctions between memory devices. Buses. A bus is a physical group of signal lines that have related function. Buses allow for the transfer of electrical signal between different parts of the computer system, and thereby transfer instruction from one device to another. For example, the data bus is a group of signal lines that carry data between the processor and various subsystems that comprise the computer. The width of a bus is a number of signal lines dedicated to transferring information. For example, 8-bit wide bus transferred 8 bit of data in parallel. The majority of microprocessors available today use the 3-bus system architecture. The 3 buses are address bus, the data bus, and the control bus. The data bus is our picture on slide show 3-bus system. The data bus is bidirectional. The direction of transfer being determined by the processor. The address by carriers of the address which point to the location in memory. Processor operation. There are 6 basic types of access that a processor can perform with external chips. The processor can write data to memory or write data to input-output device, read data from memory or read data from input-output device, read instruction from memory, and perform internal manipulation of data within processor. In many systems, written data to memory is functionality indicated to written data to input-output device. Similarly, reading data from memory constitutes some external operation as reading from I/O input-output device or reading of instruction from memory. The internal data storage or processor is known as register. The processor has limited number of registers, and these are used to hold the current data operating data operands that the processor is manipulating. ALU, the arithmetic logic unit, ALU, performs the internal arithmetical manipulation of data in the processor. These instructions that are read and execute by processor control the data flow between the register and ALU. The instruction all control arithmetic operation performed by ALU via the ALU control input. Our picture show on slide ALU block diagram. Whenever instructed by a processor, the ALU performs operation typical one or more values. Each architecture has its own unique ALU features, and this can vary greatly for one processor to another. However, all the just variation on theme and I'll share the common characteristic just described. Interrupts. Interrupts, also known as traps of exception in some process, are technical diverting the process from execution of the current program, so that may deal with some event that has occurred. Such an event may be an error from peripheral or supply that an input-output device has finished the last task it was given, and it is now ready for another. An interrupt is generated in your computers every time you type a key or move the mouse. Interrupts free the processor from having to continuously check input-output devices to determine whether they require service. When an interrupt occurs, the usual procedure is for the processor to same its state by pushing its register. Hardware interrupts. There are two ways of telling when an input-output device is ready for next sequence of data to be transferred. The first is busy waiting or pulling. Memory. Memory is used to hold data and software for the processor. There is a variety of memory types, and often a mix is used within a single system. Some memory will retain its contents while there is no power, yet will be slow to access. Other memory devices will be higher capacity, yet will require additional support circuitry and will be slower to access. Still, other memory devices will trade capacity for speed, yielding relatively small devices, yet will be capable to keeping out with fastest of processor. Software interrupt. A software interrupt is generated by an instruction. It is lowest priority interrupt and generally used program to request service to be performed by system software. RAM, rendered access memory. This is a bit of a misnomer, since most all computer memory may be considered random access. RAM is RAM is a working memory in the computer system. It's where the processor may easily write data to temporary storage. RAM is generally volatile, losing and contents when the system loses power. Any information stored in RAM that must be retained must be written to some form. RAMs generally fall into two categories: RAM and dynamic RAM. First, also known as SRAM, and dynamic, also known as DRAM. SRAM parts of logic gates to hold each bit of data. SRAM are the fastest from RAM available, require tile external support circuit, and have a relatively low power consumption. Their drawback are that their capacity is considerably less than DRAM, while being much more expensive. Flash. Flash is newest ROM technology, ROM technology, and now dominant. Flash memory has the reprogrammability of EEROM, and the large capacity of standard RAMs. Flash chips are sometimes referred to as flash RAMs, or flash RAM. Since they are not like standard RAM or standard RAM. Flash is normally organized as sector and has advantage that individual sector may be erased and rewrite without affecting the contents of the rest of the device. Typically, before a sector can be written, it must be erased. It can just be written over as with a RAM. And finally, principles of modern computer architecture, embedded computer architecture. What a computer is used for, what task it must perform, and how it interacts with humans, system determined, and functionality of the machine, and therefore its architecture, memory, and input-output. Arbitrary desktop computers is shown in it has variety of input-output devices for users' input, keyboard, mouse, and audio. User output, display interface and radio, and connectivity, networking, and peripheral. The fast processor requires a system manager to monitor its core temperature and supply voltage and generate a system reset. Large-scale embedded computers may also take the same form. For example, they may act as network route of gateway and will require one or more network interface, large memory, and fast operation. Many microcontrollers also have analog input, allowing sensors to be sampled for monitoring or recording purpose. Thus, an embedded computer may measure light level, temperature, vibration, and acceleration, air or water pressure, humidity, or magnetic field, to name just some. And finally, all of the possible devices and interfaces described previously may be also implemented through the bus interface and appropriately chosen peripheral. A bus interface provides enormous possibility.